So let's stop in the middle here and see if you have the right common denominator, because if you didn't get the right common denominator, everything's going down the drain. So factor that, difference of perfect squares, nice. Take the 3 outside. So our common denominator needs to cover both of those and both of those. What does it need to look like for both of these and both of these to be inside of it?
Isn't 3 times m plus 2 times m minus?
Yeah. Doesn't it need that to cover this one? Okay. And then it needs this also. What do you notice? Do we already have the m plus 2 covered here? But how about the 3? Is there a 3 down there yet? So there's my common denominator. So both of those are in there, and both of those are in there perfectly. And no more. You don't want more than that. What?
Equal 1. You get 1. I know. So you can cancel I know. Because then you can cancel. You can cancel that and you can cancel that. Yeah. Well, wait. No. No. It's 3m plus. Wait. No, but
Oh, because the second one is 2m.
it's.
No, because one of operations, that's not okay.
It can't.
Because that's 2m plus 2. It's 2 and yeah.
So it's.
Yeah, I know.
3.
Yeah. Go back.
Like, I think the mistake is thinking that you can't. You can't. No. Well, sort of.
Okay, I got something else.
Wait, Mr. DeLucia, what is right?
Wait a second. At first we got 1 and then you said.
I like this.
Sure.
No, it is 1. Because then you can just cancel the 3. No, you can't. And then it's just m plus 2 and m plus 2. And it's 1.
So what does this need?
Just
3. What does this need?
Yeah, it's 2 m minus 2.
M minus 2.
Then you get 3m plus 2.
So it's 3m
Well, yeah.
plus. Take the 2 inside.
I think it's just 3 plus 2.
2m minus 4 over d for the denominator. And what does that make?
5m
5m
minus
Wait, what?
minus 4 over.
denominator.
Wait, and what just happened?
Yeah.
I just put the numerator together.
super, where the bottom stays the same.
So what's this D?
What is that? Oh, you mean the denominator?
Yeah. It's just being economical with time. I should have put the whole... I'm not going to do anything with that, so I just put a D to remind myself there's a denominator there. You can do the same thing if you want.
But can't you cancel down? Can't you cancel m minus 2 and m minus 2?
Here?
Yeah.
No, because you've got an adding going on there. If it's separated by addings, it's exactly, you can't do that.
Okay.
Anyway, I think you get the idea here.
I was reading it like backwards, like look at this way, so I thought you were gonna
What about these tricky denominators? Are they the ones that are exactly backward ones again? But it's not the top and the bottom. If they were above and below the numerator or denominator, they can cancel down to -1. These are not like that. They can't just cancel because it's not like this one over this one. But what you do is you don't do. Oops, that's going out over there. Can I factor that -1 out of the bottom here? You probably don't exactly know why I would do that, but if I take a -1 out of the bottom, what will that become? How can you take a -1 out of those two? A negative times what makes 8?
8 plus 1.
A negative times a
Yeah.
negative. And how about the y? -1 times what makes a -y? I don't know if I just blew some of you away, but factor a -1 out of that, you get this. And what about this minus a minus? You watching? What's minus a minus? Minus a minus is a plus. And what does that do to this? It turns this into a plus, so this goes away, plus, and then we take the 1 back in there, and we get a y minus 8. And now what's going on here? Do they have exactly the same denominator? So what we did was, if they're exactly backwards like this, you can take a -1 out of this, put it with this, minus a minus makes a plus, and that will switch these exactly backwards, and it'll be y minus 8.
So subtraction just doesn't exist.
So
That's
now it's an adding problem, because a minus and a minus make a plus, and it's an adding problem.
never existed. The question never existed in the first place.
Okay. Do they have a common denominator? Yes. Too much TOK around there. So, see if you have any idea what I was
Can you go
talking
back
about.
for a second?
Try that one. D and a minus D and a 3 plus 3. So you end up with the same mess as you had originally.
So you want to do it with this side.
Probably that. Now you've got 3 minus D and 6. Are these guys exactly backwards? Yes. Yes. You can take the minus out of this one or this one, but only take a minus out of one of them. If you, yeah, take a minus out of one of them, maybe this one. How do you take a minus out of this one? You change the two signs. That will be minus D plus 3. Does that work? What's a negative times negative? Positive. What's a negative times positive? Negative. This works perfectly. That will stay the same. What does a minus and a minus make? A minus and a minus is a plus. And what is this denominator in the end? 3 minus D. Are they exactly the same denominators then? Yes. So it would be 6 over 3 minus D.
Wait, if you kept D minus D, would it be negative 6?
Yeah. Or this. If you took the minus 1 out of this one instead, it would look like that. We want to divide fractions. How do you divide fractions? You leave the first one alone and tip the second one upside down. In this form, you cannot tip this upside down because of this plus 1. Could you tip that one upside down nicely and it makes a nice little fraction? What happens when you tip 1 upside down? You just get an upside down 1?
You have a 1 over 1 plus 2, so a negative 1.
Yeah, exactly. Okay, so what you do is you get one fraction here. If you have one fraction here, then you can tip it upside down and not worry. So how do you get this to just be one fraction? You need a common denominator. What's my common denominator going to be? One minus 2s. So I'm going to move this over here. Take this. I want to flip this upside down. To do that, I need one fraction here, not a binomial. So how do you get one fraction here? You get a common denominator. What's a common denominator for this one and this one going to look like? The only denominator you have is that one. And what do you do about a fraction here?
So it's 1 plus 1.
And how do I get the common denominator on this side? Can I get this denominator to look just like the other denominator? What does this need to multiply by to have that common denominator? And this times 1. So 1 times this plus. Do these subtract each other? So I'm sure half of you have no idea what just happened there. But to divide fractions, you need to turn the second one upside down. To turn that upside down, you need to get it to just be one fraction. And the only way to get this to be one fraction is to have this be the same denominator as this. How do you get that to have the same denominator as that? You just force it by multiplying by this. And then what will you have? You'll have your common denominator. So it's this plus this all over your common denominator. These subtract each other, leaving that. Now we can start the problem. Why did we do all this? So that we could turn it upside down. How do you turn that upside down? So instead of dividing by this, we're going to multiply by the reciprocal. So we turn this fraction into something we can flip upside down. What are we going to do with this now? This is now multiplying, isn't it? It's not adding or subtracting. We don't need a common denominator. We need to multiply this over here. How do you multiply this over here? Is it going to be this times this and this times this?
What do you want to make the negative one, like 1 over 1? To make it easier.
Can. Okay, so this has to multiply here, and then this has to multiply here. This is no different than something with a multiplier outside. You've got a little subtracting problem with a multiplier outside. What would you do? Wouldn't you take the 4 in? Yes? That's all we're doing here. Is taking this here and taking it here. What happens when this multiplies over here? Will this multiply this? And this will multiply this? I always write my S's like 5s. What happens when this multiplies minus 1? What's minus 1 times all that stuff?
Minus 1 plus 2.
So this times this. Take the minus 1 up there. And 1 times 1 is 1. Now what? How can we ever add any of that stuff together? We need a common denominator. Does this already have a denominator? How do we get this to have the same denominator? Multiply by what's the common denominator? These will now have the common denominator. You put the numerators together. So this is 2s minus 4s squared. And what's this going to be? So this is sort of way above your syllabus. I don't know why they have such a hard problem. This is more of a pre-calculus kind of thing, or a second year IB kind of thing. Anyway, these now have a common denominator. The numerator will be 2s minus 4s squared. This one we have to FOIL. Minus 2s minus 1 and plus 4s squared plus 2s any like terms? What about these minus 4s squared and plus 4s squared? 0. What about the plus 25 and minus 25? I mean the minus 2s and the plus 2s?
0.
0. What's the only thing left?
2s minus 1.
These canceled each other. Minus 2s canceled plus 2s. What's left is 2s minus 1 and 2s plus 1. What about this one? Rewrite it like this. It's this divided by that. One thing that would have made the last problem easier is if we got a common denominator here and a common denominator here. The master plan is to tip that upside down. You can't tip it upside down when it looks like this. You have to turn it into one single fraction before you can tip it upside down. If you have to do that to this fraction, you might as well do it to this fraction as well. Get a common denominator for this one. Make it one fraction, and one fraction. How do you get a common denominator for these two guys? XY? Yes? And what does this need? Have XY? It needs an X and a Y. This needs a Y. And what does this one need to have an X and a Y? It needs an X. So what will this one look like? Y minus X. Y minus X. What's the common denominator for these guys? How do we add those? We need a common denominator. This has x. Can we turn that into x?
It's just one.
There's my common denominator. It needs an x and it needs a 1. What does this need to have the common denominator? It needs an x. And what does that make? X plus 1. So that had the common denominator already. This needs x on the bottom, so you need an x on the top as well, so multiply there. Why did we do that?
So that you can flip it.
So we can flip it. Good. We need to flip that second one though. Anything can cancel? Acorn said these two x's can cancel. Are these guys multiplying? And that guy's outside multiplying?
Yeah.
So they're all multiplying here, we can cancel. So that x will cancel with that x. So the x's are gone there. And we get y minus x over y times x plus 1. Why don't you start that one? See how far you get.